let's talk about what a variable is. It's something like an x, a y, a z, some letter, right? And actually it can be a letter in English, a letter in Greek, whatever. Some letter, some symbol used to represent a number or something that we just don't know yet. And actually sometimes it can be where you may have an idea of what it is, but you want to represent a pattern. So the idea is variables are used a lot of times to represent a number. A lot of times where you could think about that number is kind of a question mark. We just don't put question marks everywhere because that would be kind of messy. So for example, if I were to say, okay, well, what plus what equals 4, x equals 4. So again, what I'm trying to illustrate to you here is that these letters x do represent some numbers, and we look at the pattern between these x's. In other words, I have a single x plus the same single x. A number plus the same regular number equals 4. And hopefully you're thinking, oh, well, since there's nothing fancy happening, I just have a number plus itself, because there's no change here in our symbols. That's 2. 2 plus 2 equals 4. So in this case, we were using x to represent 2. Sometimes it can be a bit more arbitrary as far as maybe sometimes you can't come up with just one answer. You may have more than one answer for this x, or this variable x, y, z, a, b, c, whatever it is you want to use, okay? Right here. This right here is what we call an expression. More technically, it's a variable expression because notice we have some letters mixed in here with our numbers. We say expression instead of equation because also notice there's no equal sign. So in this lesson today, we are not exploring how to solve all the way like we did here with this example where we had something equals 4, x plus x equals 4. Instead, we're saying, you know what, let's just explore the basics. Let's just look at these letters mixed with numbers and see how we can talk about the way they relate and possibly simplify later. So there's no equal sign. Our goal is not to solve, it's just to get comfortable with how these things relate together. We do want to get comfortable with the terms, though, that we're looking at. The first thing that you'll notice as you look across this example, okay? Most people would naturally look at 3x squared as one piece, and this minus 5y is another piece, 2xy, x, and 7. And of course, when we're looking at it, the sign right in front, remember from positives and negatives from integers, does tell us the sign of the number. So for example, this piece here is a negative 5y. Well, instead of using the word piece, we call these pieces terms. And what we say is, okay, well here we have a string of pieces, a string of terms attached by plus and minus, essentially, right? And we're going to look at some other things. For example, notice for me that some of the pieces have x and y and some of them do not. Some of the pieces have a variable attached. We'll call those variable terms. So for example, the 3x squared right here, the negative 5y, the positive 2xy, and the minus x. Those are all considered variable terms. And then on the end we have just a regular number, the negative 7. That's a constant term. That's just a plain number. As you progress through mathematics, is a lot of times we use these relationships to model real-life things. Now, we're not quite there yet. Right now we're looking at basic principles to help us build up to that point. But this is a really good thing to notice because as you look specifically at word problems later on, you'll notice that the constant term, the plain number, is kind of like a set thing. In fact, in business classes, you'd probably say it's a set cost, something that's not going to change. Your rent every month is probably not going to change because it's always the exact same fee. So it's important in these expressions and later on equations where we start putting in the equals to notice things like this, to notice that there are numbers like the negative 7. No matter what x and y are in this situation, 7 is 7. It's not changing. Versus our variable term in the front here, we have several in this expression, but let's look closer at 3x squared. With this one, depending on what that x is, notice the value of this piece as a whole will change. It varies. It changes depending on what we put in for the x. So again, guys, these are expressions. In other words, there's nothing fancy here. These are the easy type. The type where you look at a very simple relationship, but really there's not a lot of restrictions because there's no equal sign. In other words, I have to tell you what to substitute in here, okay? Notice something. As I did this, as I plugged in my a equals 5 everywhere I had a, and my negative 3 in place of my b everywhere I had b, I used parentheses. You don't necessarily have to do that every single time you substitute, but it's a good thing to start off with, because literally we are just plugging this number in where that original letter was. And as we plug in, you should imagine a little portal with parentheses, because it does make a difference sometimes if you have a negative sign specifically. So in this case, notice that when I plugged in the negative 3 for that b squared, look, I did put it in parentheses, and that means a world of difference to me. Recalling from the last section, of course, that a negative 3 within parentheses to the power of 2 is quite different than this situation here, negative 3 squared. When it's like this, like I have it on the right of the page, negative 3 squared, remember it would be negative in front of 3 times 3, right? So negative 9. In this case, however, we have it in parentheses. So it actually is going to mean to us negative 3 squared, the entire thing repeating itself twice. So a negative times a negative, now I have a positive, and that's going to be a positive 9. So quite different, guys. Once again, I'm trying to emphasize to you, use parentheses, unless you're completely sure that it won't make a difference. And the rule of thumb is, if there's a negative, yeah, you want some parentheses there. Let's go ahead and simplify this. Again, we're going to use order of operations. And I'll write it out for us. It's not too in-depth here, but I'll write it out anyway, just so we can remember. Please excuse my dear Aunt Sally is what we learned recently, where multiplication and division have same priority, and addition and subtraction also have same priority. And we work through this process left to right, just like you read a book, left to right. Okay, so the first thing I'm going to do is say, do I have any type of grouping symbols? Well, yeah, we have lots of baby parentheses, not a lot going on inside those. But the main thing you may notice is this big fraction bar. Remember, we said that is a grouping symbol because it's dividing the top separate from the bottom. So first, I'm going to look at the top of this thing. So as far as 5 squared plus negative 3 squared goes, when I look up here, I once again say, do I have any grouping now that I'm up on top? No, not other than these baby parentheses where I can't do anything on the inside. So I'll go to the next level of order of ops. Do I have any exponents? Sure. Let's hit them left to right. I have 5 squared, so 5 times 5, that's going to give me 25 plus, and if you'd like to go ahead and do both in one step, we'll do that since I'm assuming you've practiced some now. That negative 3 squared we discussed over here is the same thing as negative 3 times negative 3, so we're going to get positive 9, so plus 9. And again, show yourself as many steps as you need to, okay? And then on the bottom we have this right here. Now really on the bottom I haven't spoken a lot about that because the parentheses didn't make as big of a difference. In fact, if you'd like to drop them, just like I did the one on 5 as I recopied it, that was on purpose, you're welcome to do that. There's nothing attached as a power, and there's nothing attached on either side by multiplication, so it's okay to go ahead and drop parentheses whenever you're ready, as long as you're careful and don't lose your sign altogether when you have negatives, versus up here with that negative 3 squared where you really needed the parenthesis. I really can't emphasize that enough. Okay, so down here we're going to say, okay, well, we're continuing on top. I'm still in this grouping of the top, so 25 plus 9. That looks like a 34 on top, and we still have our 5 and our negative 3. Now on the top we say, okay, that's been completed. So let's look at the bottom. 5 and a negative 3. Let's see, they're different signs, remember, so 5 minus 3 is 2, where the 5 was a positive number, which is larger, so we keep the positive there. So we'll say, okay, that is equal to 34 over 2. Now remember, on your test, you do not get a calculator. While you're practicing these, feel free to use the calculator if it's something that you know you can do by hand. But remember, to fully simplify this right here, we have an even number over an even number, so you can use long division if you need to, or just... So yes, this right here is equal to 17. Let's try one more example like this. Once again, evaluate basically just means substitute. So here we have an expression where they're telling us what the different letters are equal to, and our only objective here is to substitute those letters in and see what we get when we simplify. On this one, well, we can write parentheses anyway if we want. You can never write too many of them. It doesn't really matter. They're just good precautionary things to use. For y, we said that y is going to be represented by a negative 4. So here for the y, I'll put in negative 4. And again, I'll go ahead and write parentheses just to make sure that you guys are comfortable doing that. And then our last letter, we have a z, equals negative 3. So we'll say, okay, plus negative 3 squared. And really, even though we were very careful as we plugged in, notice here that we can already write it a little bit cleaner for ourselves if we'd like to. These parentheses in here, even though it is good practice to write them, they're not completely necessary. Nor is this parenthesis right here, because there's no negative. So let me rewrite it a little bit cleaner. I'm going to drop parentheses in any case where they're not really preserving a lot. In other words, in any case where there's not a power attached or a multiplication sign in front. This one on the end, I am going to keep that parenthesis. And again, I do parentheses. Sure. As I go left to right, this is the first set I see. So 2 plus a negative 4, those have different signs, giving me a 2 of difference. I keep the negative. I cannot drop these parentheses yet. Notice, I kept saying to you guys if there's nothing attached or nothing in front by multiply, but notice there is something in front by multiply. So I need to keep these, or at least put a symbol of multiplication in between. I can't just write the number by itself. I have to remember that there was a multiplication happening right above it. So I'm going to keep it like that. Now we have plus. I'm going to recopy the entire problem. Okay. Next thing we do I have any grouping symbols? Well, sure we do, but there's nothing inside of those to do. So we'll move on to the next step. Do I have any exponents? Yes, let's go left to right. 2 cubed. In other words, 2 times 2 times 2. 2 times itself 3 times. That sounds like 2 times 2 is 4 times 2. How about an 8? So 8 minus 2 times negative 2 plus negative 3 squared. Once again, we go back through our order of ops. Do I have any parentheses? No, we're set. There's nothing to do inside of those. Any exponents? Sure. Here on the end. And again, this time, because of those parentheses, we know that's a negative 3 times a negative 3. I'll write it over here. Notice that I tend to use scrap or kind of side work paper. I'm putting it so you can see it, but that's on purpose. I don't tend to put simple little math things inside my main problem. I keep this thing clean so that I can proofread it as I go back to make sure there's no mistakes. 3 times 3 is 9. A negative times a negative is a positive. We have a positive 9 here. Let's recopy what we have. Again, I recopy a lot because I like to be able to proofread my work in case there's any mistakes. Okay, parentheses. Nothing of importance since we can't do anything here. Exponents, we got them all out. Multiplication or division, remembering they're the same level, looking left to right, right there. Negative 2 times negative 2. 2 negatives give me a positive, and that looks like a 4. Since it's a positive 4, I will write positive in front of it and rewrite the rest of the problem around it. Now it's all the same level, it's addition, so we just go left to right. 8 plus 4, 8, 9, 10, 11, 12. Bring down our 9. 9, 10, 11. Carry that 1, that looks like a 21. We have now evaluated our entire expression by plugging in numbers for the